Hi, welcome. In the previous lesson, we were looking at the states of Mara, and we reached to an extent where we saw that normally some substances can either be pure substances or they can be a mixture. So we will first of all start by discussing what a mixture is or what a mixture is made of. So a mixture is a blend of two or more kinds of matter, each of which retains its own identity and property. A mixture is a blend. A mixture is a blend of two or more kinds of matter, two or more kinds of matter, each of which retains its own identity. Each of which retains its own identity. So we will take an example here to make things easier and precise. If you are having a plate of different types of maybe vegetable salad, so you are having here a plate, you are having different types of foods, you are having different types of fruits. They may be watermelons, they may be pieces of orange and so forth. So all these together, they make what we call a mixture, basically because each of these fruits will maintain its identity. Each of these fruits will maintain its identity. So the parts or components of a mixture are simply mixed together physically and can be separated. So the parts or components of a mixture, the parts or components of a mixture are simply mixed together. Are simply mixed together physically and can be separated. And can be separated. So just like if you have your vegetable salad, you could easily separate the carrots from maybe the spinach or the tomatoes. The same thing can happen also in other mixtures. So because mixtures can contain various amounts of different substances, a mixture's composition must be specified. A mixture's composition must be specified. This is often done in terms of percentage by mass. This is done in terms of percentage by mass. Of percentage by mass. This is done in terms of percentage by mass or by volume. For example, if we take sodium chloride, which is normally a solid of 5%, then and maybe 95% of water, which is a liquid, the mixture that are formed here will be a solution. So you'll have here a solution of sodium chloride. Sodium chloride solution. So this sodium chloride solution will contain, of course, a mixture of water and a mixture of sodium. So mixtures that are uniform in composition are said to be homogeneous. Mixtures that are uniform are said to be homogeneous. So if you look at them, you will not be able to distinguish between one of its composition. So if we take a solution, for example, of salt, when it is mixed, you will not be able to see the salt and say this is salt, and you will not be able to say this is water, or this water doesn't have any salt. So homogeneous mixtures are also called solutions. Homogeneous mixtures are also called solutions. Homogeneous mixtures are also called solutions. They are also called solutions. And the example we have just given there is an example of a mixture. We have another set of mixture which is referred to as being heterogeneous. So mixtures that are not uniform throughout, that are not uniform throughout, mixtures that are not uniform throughout are said to be heterogeneous. So a heterogeneous mixture is a mixture which is not uniform. If you take an example, for example, of clay and maybe water, if you mix these two, what will happen is that you will have your glass of water, and in the bottom there will be the clay will settle at the bottom, and on top here you will have water. So this mixture will not mix evenly. This mixture will not mix evenly. So some mixtures can be separated by filtration or vaporized to separate the different components. So we will go through a set of substances here and see. So what we have here are some mixtures and how they may be separated. For example, you might have a mixture of barium chloride, barium chromate, and this can be separated from the solution in the beaker using filtration. So when you filter, barium chromate will remain on the filter paper and the liquid or the solution will go down. So you could also use a machine called a centrifuge. So using a centrifuge can be used to separate certain solid components. The centrifuge spins rapidly. So what it does, the centrifuge, it will spin rapidly, which causes the solids to settle down to the bottom of the test tube. So if this is the test tube, you put it here into the centrifuge and you run the machine, it will be moved round and round very fast. And as this happens, the mixture will be separated. Some of it will settle down, as you can see here. Some of it is settled down, and the other remains up. And you can now pour out this and remain with this, and you'll have separated. In chromatography, the components of an ink can be separated using paper. So you can use paper chromatography, and depending on the color of the ink, all the different colors will run at different rates, and as they run at different rates, you will see all the different pigments being displayed there. Let's look at a video here to make it easier for us. Here we have separating mixtures. We will look at how different mixtures can be separated. So the components of a mixture usually can be separated by physical means such as distillation, evaporation, precipitation, filtration, and paper chromatography. We can also use manually, we can separate them, or use a magnet, or using a centrifuge machine, or by use of a centrifuge machine. We take an example here. We are having these fruits. So these fruits here can be separated manually by you picking up one fruit from the other. Or maybe you are having soil here. If you have soil here that you want to separate, you can take these different components and mix them with maybe water, and then from here you can put them into a centrifuge machine and run the machine. As you run the machine, as we said earlier, what will happen is that the components of the mixture, which will be now in, of course, a mixture of water and different substances, will be separated by the solid substances settling down and the liquid going up. This is just but one ways in which we can separate substances. We could also, this is now the centrifuge machine, as you can see it. As it is put on, it will run and run, and these substances, as we saw, will be separated. So you put them there into the machine and run the machine. You see how fast the machine runs. Because of its speed, the substances will be separated. The substances will be separated. What you have in the end. The next one, we could use a filter paper. So we could use filtration. You take a mixture as we saw earlier, then you pour it down, and you will see that some of the substances will remain in the filter paper, and the other substance will go through it. That is just but one way of separation, and we call it filtration. We call this filtration. Another type of separation is by use of distillation. So in distillation, you will take a solution mixture, then you will provide a source of heat, and as they boil, these materials boil, we know that different liquids will boil at different temperatures. So as the first one comes up or changes into vapor and pass through the tube, it will be condensed by this condenser here. Here we have cold water running through this condenser and cooling it and converting it back into a liquid, and it is collected here. This is the filtrate. What we collect here is the filtrate, and this filtrate will have been separated from the solution. So you can separate a solution by using condensation. Here you see exactly how you are supposed to set your apparatus. We have the distilling flask. We have here salt and water. We have a Bunsen burner. So as you burn, the water will go through here in form of water vapor, and as it reaches the condenser, it will be condensed and it will be collected here as pure water. It will be collected as pure water. Other forms of separation may involve, for example, the formation of solid crystals. So from a homogeneous solution. So from a homogeneous solution, you can form crystals. Then these crystals can be pulled out of the solution. These crystals can be pulled out of the solution. As you see here, a crystal is being formed, and as the crystal forms, it will be easy for it to be removed from the solution. It will be easy for it to be removed from the solution. Another method that we could use is, for example, use of paper chromatography. As we saw earlier, you just put a drop of ink here, and after some time, the ink will start to move or to flow through the filter paper, or the chromatography paper, and different pigments of the ink will be displayed through the paper. This is also a way of separating a mixture. It's a way of separating a mixture. So separation of mixture can be separating of homogeneous substances, or even you could even separate heterogeneous substances. You could even separate heterogeneous substances. So let's look at pure substances. Let's discuss about pure and impure substances. So we will discuss about pure and impure substances in terms of science. So we will stop here, and in the next video we will look at purity.